Hey everyone, what's up? Let's continue building our chess game. So in the last video, as you remember, we created a compute all legal moves method inside this chess player base class, which basically computes all the legal moves that a player can make at any point of the game. So it does that by combining the legal moves for each piece he controls, and it computes the legal moves for the pieces using this compute legal moves method that we have also created in the previous video. So this is an abstract method, so we must implement this in our sub piece types. So in bishop, knight, pawn, etc. But before we begin to implement this method, we need a way to access a square from another square. So let me show you, let me explain you what I mean on an example right here. So let's say we want to compute the legal moves that this knight can make. So there are 8 possible squares that this can go. And in order to be able to access, for example, this square, I need to be able to relatively access this square from the initial square. So for example, this square is 2 rows up and 1 column left relative to this initial square. So I need a method where I can say, so you go -1 horizontally and +2 vertically and give me that square. Let me show you. So let's go to our square class, and we're going to create a new method here, public square. So get adjacent square. I'm going to provide 2 offsets. So int horizontal and vertical. In this method, I'm going to use this board reference to access another square according to my current position and my offsets. So that's actually pretty easy. So return board get square. We have already defined this method. So I'm going to add my offsets to my current position. So horizontal plus call and vertical plus roll. That's all I need to do. So in this way, I can now access an arbitrary square relative to my initial position. But there's something else I need to do. So you see, I can be at the corner square. So let's say I'm here, and here is the top right corner of the board. So if I want to access something here, I will get a null pointer exception if I don't take care of this problem. So let's go to this get square method actually. So it basically does that. It accesses an element from a 2-dimensional array. So if so you see this is 8 by 8. 2-dimensional array is 8 by 8. So if I want to access the row 10, for example, it's going to throw a null pointer exception. So here in this get square method, I have to check that my indices are not out of bounds. So I'm going to add here a simple condition. So if row, let's put it in parentheses, row smaller than 0 or row greater or equal to length, so this is 8, and 8 means the ninth column or row because it starts from 0. And also the same thing goes for the columns. Call smaller than 0 or call greater or equal to length. So if this condition is met, so this means that my indices are out of bounds. In that case, I'm going to return null. Only if I'm not out of bounds, so this row and column is valid, then I'm going to return the element. Now we can use this get adjacent square method in our compute legal moves methods that we are going to implement in our piece types to access squares relatively. So I guess I'm going to start by this night class, implementing this method for the night class, but I'm going to do that in the next video. So see you in the next video and take care.